Hey guys, we are here today looking at the motion of falling objects. This first track is a track of me dropping a ball. You'll see that the ball is accelerating. This graph on the right here shows the position versus time, and it shows a non-constant slope, therefore showing acceleration due to gravity. If we look at my track of my box, we'll notice that this has a different result. The velocity is more constant due to drag, viscous drag on this object. So therefore, constant velocity on the way down, drag forces are balancing out the gravitational force. I actually modeled one of these. I actually modeled all of these situations. I don't have time to go into all of them. I modeled the box with gravity and drag, the box with gravity, the ball with gravity, and the ball with gravity and drag. So I'm going to show you the first one I did. This is just a ball with gravity. And this is going to show you that the ball is just accelerating because the only force is gravity. Which is true. So then if we go over here to Excel, we see all the data that we've gathered. The observed position here, this is a function, ball position as a function of time. We'll see that the blue line represents the observed position of the ball. And then when I did my gravitational prediction, which only incorporated gravity forces, which was the red line, we see that was pretty accurate for this blue line. And the reason for that was because gravity was basically the only force acting on that ball. Drag played a minimal role. However, when we did model the drag, this green line, the constant of proportionality had to be so small to make it fit the data. 0.00001 was the drag proportionality constant. Therefore, the drag force was nearly zero. So basically, all of these lines are showing that the ball didn't experience a whole lot of drag, and therefore it was accelerating downwards due to gravity. It did not have a constant velocity, and the net force on that was not zero. Yet when we see the box, we see a different situation. The blue line is representative of my observed position, and we see that doesn't really accelerate. It's pretty constant velocity. However, when I did my prediction with gravity, and thus only incorporating gravitational force, we see something way different. We see that it would have predicted that the object were going to accelerate downward. However, that's not the case because drag was acting on this box. When I did my viscous drag and gravity prediction with a proportionality constant of 0.03, you see that really does model this blue line very well. And that's because we're incorporating the drag forces into our model. Therefore, the acceleration is basically zero because we have a pretty constant velocity here. And therefore, it's moving downward. And the net force is basically zero because those drag forces are balancing out that gravitational force. So, going to answer the questions now. So prediction for my slow object. So which prediction would show terminal velocity? Prediction with drag or prediction without drag? So it's going to be the prediction with drag because that shows the constant velocity and zero acceleration, zero net force. So that's this green line or the blue line, which was the observed, and the observed, of course, obviously represented that drag force. And this red line, the one that did not incorporate drag, does not show terminal velocity. That's because there's no constant velocity. There is no upward force to balance out gravitational force. There's no net force. The net force is not zero, so the forces can't balance out. So there's no terminal velocity here. However, I also graphed the same things with my model that had initial velocity rather. So basically, all of these guys, some had initial velocity, some did not. I did the predictions with gravity and drag. So the only ones that would show possible terminal velocities are this red line and this purple line. And the red line was a prediction of gravity and drag prediction with no initial velocity. And the purple line was gravity and drag prediction with initial velocity. So that's interesting. You'd say, oh, well, one has initial velocity, one does not, but they both have drag and gravity. So it turns out the only reason that something would have a terminal velocity is if there's a force acting up. In this case, it's drag on both of these objects. So therefore, the red line and the purple line, the gravity and drag prediction with no initial velocity and the gravity and drag prediction with initial velocity, both show a terminal velocity as possible because they both incorporate the drag force, which balances out the net force to zero, so that they have constant acceleration, zero acceleration, constant velocity, and a net force of zero. However, these blue lines, the blue line and the green line, do not have a terminal velocity because they do not incorporate drag. This blue line has no initial velocity, while the green line does have initial velocity. Yet they don't incorporate that drag, so that they both do not have a net force of 0, and they both are accelerating downwards. There's nothing to balance out that gravitational force, so therefore these do not have the possibilities for terminal velocity. So I hope I was able to cover everything. This video had to be pretty quick, but that's basically everything, so we'll talk to you later, y'all.